find how many complex solutions does this equation have, and how many solutions lie in the first quadrant, how many solutions lie in the second quadrant. I think a question we can straightforward say it will have 2014 solutions because it is a polynomial equation of 2018 degree, and hence it has to have 2018 solutions because we are talking about complex solutions. Real solution we cannot comment, but complex solution has to be 2018 for sure. Now coming to the B part and C part, that how to conclude how many solutions in the first quadrant, how many in the second quadrant. To do this thing, please understand first that argument of this number z raised to the power 2018. Okay, if suppose it is theta, then its tan theta will be, in fact this complex number z itself lies in the first quadrant because both real part, imaginary parts are positive. So tan theta here will be 1 upon 2018 raised to the power 2018. And you can see that in the denominator it's a huge number. So 1 upon this huge number will be almost 0, but definitely positive, slightly positive number. Okay, now if I need to find the argument of z, that is the number which is after taking 2018th root. Okay, so roots of this would be, by using De Moivre theorem, you can say it will be theta upon 2018 plus, because we can write theta always as 2k pi upon 2018 here. Theta is always, can be written always as theta plus 2k pi, where k can be any integer. And using the De Moivre theorem, how many times k do we write? We write k as 0, 1, 2 and so on till 2017. We put 2018 distinct values starting from 0 till 2017, and this will give us distinct positions of z on that argand plane. Okay, so these will be the argument of z, possible argument of z. Now we have to find how many of them will be lying in the first quadrant. So one of the method is that just use in equation. I think that is also not very difficult task. For first quadrant, I think we want this to be, this theta plus this thing should be lying in 0 to 90 degree or 0 to pi by 2. That means I should be having this thing to be greater than 0. Okay, and it should be less than pi by 2. Okay, let me do it on the next slide. So theta upon 2018 plus 2k pi upon 2018 will be less than pi by 2, will be greater than 0. Now dear all, please understand, because k starting from 0, for k equal to 0 definitely, because theta is a positive angle, although it's very small, and theta upon 2018 will also be very small but positive. For k equal to 0, I think this is first quadrant, isn't it? First quadrant. Now let us check what is the maximum possible value of k for which we will still be getting first quadrant. So for that, what I'll do, we will be writing this as 2k pi upon 2018 to be less than pi by 2 minus theta upon 2018. Okay, so this k will be less than, I can multiply by 2018 upon 2 pi here, then pi by 2 here, minus theta upon 2018 here, to know what can be the maximum possible value of k. If I multiply it inside it, I think we will be getting, pi will be cancelling this, 4 upon this. So I think 4 5s are 20, then 0 and then 4.5 minus this will be 2018 will be cancelled, and theta upon 2 pi. I think that is what we are getting. Now dear all, you have to understand that theta is one very small angle. One very small angle. It is almost approaching to 0, because 1 upon 2018 raised to the power 2018, you can only imagine that how small this angle would be. So if this is very small angle, okay, so theta upon 2 pi can be negligible as compared to even this 0.5. If you ask me, I think this value will be 504 point maybe 4999 something like this, because theta upon 2 pi is one very small angle. So if you subtract from it, you will be getting this. So if we are looking for k less than, okay, so here my k will be less than or equal to 504, because it has to be less than 504.4999, so it can take 504 also. So the value of k will start from 0 and it will go till 504. So for first quadrant, the values of k are from 0, 1 and so on 504. So number of solutions lying in the first quadrant are 505. Okay, now for second quadrant, I have one method which you will appreciate, although we may solve similar inequation for second quadrant also. Dear all, please see, this equation is such that if I put minus z in place of z, then also it satisfies this equation. So what I am trying to say to you that if this is having 505 solutions in the first quadrant, and putting z as minus z is also solution, so there will be 505 solutions in the third quadrant also. But total solutions are 2018. So what is remaining? Because 1010 we have already covered. So here the remaining solutions are 1008, out of which half will be here and half will be here. Because once again, if any solutions you are having in the second quadrant and just put minus sign in front of it, you will get this into the fourth quadrant. So 504 solutions here, 504 solutions here. So the final answer for this question is like this. If you want to write in that order, that for A part answer is 2018, for B part answer is 505, and for C part it is 504. Okay, I will discuss one more method for this question. Let me take one more slide for this other method. So the other method, the other solution for this method could be, for this question could be, as I told you in the previous method also, that because of this iota, this complex number is in the first quadrant, but argument is very small. So for a moment, if I ignore the fact that this iota is not there, then this question is just z raised to the power 2018 is equal to 2018 raised to the power 2018. Then the roots of this will be actually 2018, 2018th roots of this 2018 raised to the power 2018. I hope you are not confused. Okay, now the first root will definitely be at 2018. And as we do for nth root of unity or any complex number, other roots will be such that they will be, you know, at equal angles from each other like this. Okay, and there will be equal 2018 part about this origin. I hope you are getting it. And one root will be 2018, one root will be minus 2018. So among these 2018, two are real roots. So remaining 2016 roots will be such that they will be equally distributed in these four quadrants. So there will be 504 roots in the first quadrant, 504 roots in the second quadrant, 504 roots in the third quadrant, and 504 roots in the fourth quadrant. I am talking about for this only. Now after the introduction of iota, which is one very small thing as compared to, which is one very small difference in this complex number as compared to this 2018 power 2018, but what it will do, it will, you know, rotate this original line, original complex number 2018 is to the power 2018 slightly in the anti-clockwise direction. So my original number, which was on the positive x-axis, it will be now in the first quadrant. And the impact of this would be that this all the solutions, ignoring this iota and assuming that it will be a similar circle, but because of this iota, my first root will not be on x-axis, but it will be slightly inside the first quadrant. So you can think of that this root will also go into the first quadrant, this root will go into the third quadrant. But because this angle, because of this iota is so small, all other roots will not be able to cross their quadrants. So whatever was there in the first quadrant, it will still remain in the first quadrant. Whatever was there in the second, it will still remain in the second quadrant. But because of this iota thing, the roots which were there on the positive x-axis or negative x-axis, they will go into first and third quadrant respectively, and hence there will be a difference. There will be increase of 1 in that number of roots that will be lying in the first quadrant or in the third quadrant. So number of roots in the first quadrant 505, and the second it is 504, and here it is 2018. So this completes the solution of this question. This question I will rate as a good question.